Okay, so we just spent some time in class in last night's video learning the basics of elimination. As I've said, there is another method called substitution, which should you choose to do that method, you can watch that video. It's loaded. However, I feel like this is the one method to perfect. Here's why. It makes more sense, and if you substitute something in wrong and distribute, you'll make a mistake. So again, the whole point of this method is to eliminate, meaning to get rid of. So here's our steps. So elimination is a method for solving systems by adding equations to eliminate variables with opposite coefficients. Now, as you move on, you might hear of another way to do elimination. This is my way, where we add the equations always. So in order to be able to add them, we must take these steps. So there is studying involved in understanding the steps. 1, make sure the equations are lined up. What do I mean by lined up? I mean the x's and y's are on the same side. They can both be on the left, or they can both be on the right, or they could be on one on each side. Whatever it is, if x is on the left in one equation, x must be on the left in the other. After we've lined our equations up, this step, and you need to write this in on the side, please, you might not have to do this step. This step, step 2, you may be able to skip sometimes, as well as step 1. But sometimes we're going to have to multiply one or both. So what I want you to do right now is I want you to write 1 or both. It just depends upon the problem. So we might have to multiply one or both equations to generate an equivalent one. So we're going to be creating a new one that has one variable with an opposite coefficient. Another way to consider the opposite coefficients is a zero pair. Okay, once I've done that, once I've created 2 new equations so that my variables are opposites, I add the equations to eliminate the variables that have opposite coefficients. By that process, by adding the equations together, you're going to get a new equation. You then solve that equation for whichever variable is left. Sometimes it's x, sometimes it's y. Okay, so now I have the value of one of my ordered pairs. I plug that value that I just got in step 4 into one of the original equations, and no, it doesn't matter which one. And I find the other variable. Then I write the solution as an ordered pair, and I check my solution like we did last week. Let's go see what all of this looks like. Okay. So our first step is to make sure that they are lined up. So if we take a look, my y's are both to the left and on top of each other. My x's are both to the right and lined up, one on top of the other. And then even though this is kind of a diagonal, they're lined up. They're in the same position. Okay? So now that we have that, we are going to look, and I'm going to eliminate the x's. That's just my choice. So since the first equation has 3 and the other one has 1 as coefficients, they are not opposite yet. Okay, they're not the same. I'm going to multiply the bottom equation by -3. Why -3? Well, the whole point is that I create an equal equation, an equivalent equation, where the coefficient of x is the opposite of the other one. So since my first equation was a positive 3x, if I multiply everything on the bottom by a -3, I now have opposite coefficients. So let's go see what that looks like. So I'm going to take the bottom equation. If I multiply one thing, I must multiply everything. So I distribute that -3, I get -3y. I also distribute it to the x. I get negative 3x. Remember, that was my goal. And then I give it to the negative 2 and get positive 6. So now this is an equivalent equation. I can take, okay, my original and my new equation I just created. Now that I have opposite coefficients, I am able to add these two together. Okay, so now I'm going to add them. If I add y and negative 3y, I get negative 2y. And then I add 3x and negative 3x, I get 0. And then I add 4 and 6, I get 10. Remember, ladies and gentlemen, my whole point was to cancel the two x's out. And I did that, okay? We don't write 0x. That's just an unnecessary, it's just a placeholder. I don't put it, okay? So really what you get is negative 2y equals 10. Well, now you're able to solve. You divide both sides by negative 2 so that y equals negative 5. But remember, you're not done. Go plug that value back in to one of the original equations. I'm going to pick this one because for me it's easier. So I replace I replace y with negative 5. Add 2 to both sides so that I get x equals negative 3. Therefore, the solution to this problem is negative 3, negative 5. Okay, let's go try another one. So the thing I like about elimination is you don't have to solve. You don't have to isolate a variable. You just have to make sure they're lined up. So in this case, they are. Okay, my x's are with my x's, my y's with my y's, and then my constant with my constant. But if you take a look at the coefficients, none of them are the same. Well, they are the same actually. The x's both have a 1, but do I want them to be the same? No, I want them to be opposite coefficients. So I'm going to just take my bottom equation and times everything by negative 1. That gives me negative x plus y equals negative 3. So I have a new equivalent equation. I can then take the original one and my new one and add them. Because watch what happens. My x's cancel out, my y's become 5, and my constants become 10. Remember, 0x, we don't write it. So it's really just 5y equals 10. I divide both sides by 5 to get y equals 2. But I'm not done. I'm going to plug it back in. I'm going to pick this equation because I want to show you it doesn't matter which one you pick, but we always go back to the original problem. So I'm going to replace y with 2. So I get x plus 8. I subtract 8 from both sides so that x equals 5. So you have your y, you have your x, but that's not the answer. This is the answer. Your answer is an ordered pair. Okay, so be careful here because if you notice, we jump from question 3 to question 11. So make sure that you are doing this problem and this problem only, that they match. So everything's lined up. Now the dilemma is everything's identical here, but we want opposites. So it doesn't matter which one. I'm just going to take this equation and I'm going to multiply it by a negative. I can do that. It's like times a negative 1. Because what happens is I now have negative 3x plus 4y equals a positive 10. And then I'm going to add to it the other original equation. When I do this, what happens is I get 0x, 0y, but I get negative 3. So does 0 equal negative 3? Will it ever equal negative 3? No. So it's no solution. Remember, this doesn't change. If the variables cancel and the two sides are not equal, it's no solution. So let's look at this one. Now this one's actually a little easier. Why is this one easier? Well, if you look at the coefficients, they're already opposites. So all I'm going to do is I'm going to take my first equation and my second equation. When I add them, I get 0x minus 0y equals 0. Does 0 equal 0? The answer is yes. It will always equal 0. Therefore, it's infinitely many, meaning the same reason. When the variables cancel and the two sides are equal, it's infinitely many. So ladies and gentlemen, we've thrown at you a lot in a short period of time. You need to ask for help in class. Don't just sit there and think that it's magically going to finish itself. Please ask. That's why we're here.